Okay, the rest of Chapter 9 we are going to do a whole bunch of hypothesis testing, and the first one is the hypothesis test for the difference between two means and the z distribution. Again, on this you can do it by putting in the data or by doing the statistics. So this first one is one where we're going to use the data. A researcher hypothesizes that the average number of sports that a college offers for males is greater than the number of sports a college offers for females. A random sample of the number of sports offered by colleges for males and females is shown below. At the alpha level of 0.10, is there enough evidence to support the claim? Assume the standard population standard deviation 1 and 2 are both 3.3. So this is the same problem we did when we did the confidence intervals and we had the data for the z-test. And so again, you may want to pause the video and go ahead and get all of your data in there. To put your data in, again, you are going to hit the Stat button and then Edit, do number 1 to put your list in. If you need to, cursor up to the top and clear and enter. I've already entered my data in, but you may want to pause the video and get your data all entered in, and then we can go on to the next part. So it says once we have our data entered into list 1 and list 2 by pressing the Stat button, we're going to put Stat. So again, I'm going to go down to Stat. I'm going to cursor over to Tests. So cursor over so Test is highlighted, and we are going to press number 3 or cursor down to number 3, whichever way you want to do that. If I cursor down to number 3, you can see that I have the 2 sample z-test is what I'm going to do. 2 sample z-test. I'm going to enter on that. And we are going to use the data. So if data is not highlighted, go to data and enter and highlight that. Standard deviation 1 and 2 for this problem both said we were going to do 3.3. So I'm going to put 3.3 in for standard deviation 1 and for standard deviation 2. List, we're going to use list 1 and list 2. Those should be in there, but if they're not, second function 1 does list 1, second function 2 does list 2. Frequencies, both 1. And then we want to do our hypothesis, our alternate hypothesis. In this case, we are saying that the males is greater than the females. So we are going to do U1 is greater than U2. Enter on that. Cursor down. And then once you're on the word calculate, you're going to enter to calculate. So when we're looking at U1 being greater than U2, our Z value to 4 decimal places would be 0.9394, 0.9394. Our P value, 0.1738, 0.1738. And from there we can go ahead and answer the questions. So it says here, is this a left-tailed test, a right-tailed test, or a two-tailed test? Since we're doing a greater than, it is a right-tailed test. For our critical value, for the critical value, you can use the Alex calculator and do the inverse norm of 0.90. I'm going to go ahead and do my calculator here. And so if I do the vars key, if you remember, and, oops, I have to do second function var key. So second function, the vars key, and inverse norm, which is number 3. Enter on that. The area, since we're doing 10% to the right, it's 90% to the left. So we use 0.90. The mean is 0, the standard deviation is 1, and if I do that, then I can see that my critical value is 1.28, 1.28. Now if you're using the Alex calculator, which is probably easier to use than the graphing calculator, you would do a positive Z, since I'm doing the area to the right, so Z sub 0.10, Z sub 0.10 on the Alex calculator, and again to 2 decimal places you would get 1.28. So, wants to know if we should accept or reject the claim. Again, I like to draw my picture out here, if I can find my picture on my thing. There we go. So our critical value was 1.28. The null region would have been the first area here that's to the left. The alternate claim is the one that's to the right because we were checking the greater than. Well, my test statistic was 0.9349, which is before the critical value, so it actually is less than the critical one instead of greater than the critical one. So in this case, we're accepting what the null was. If we accept the null, we're going to then reject the claim because the claim was the one that says, is it greater? If we do our p-test again, we could compare the p-value of 0.1738 is greater than 0.10, which is our alpha value. And if your p-value is greater than your alpha value, you're going to accept the null, which in this case means I'm going to reject the claim. And so that's how that would go. I'm going to pause this for a minute and grab my next piece of paper. So you are then going to go ahead and try the next one on your own. It says past records suggest that the mean and the annual income of teachers in the state of Florida is greater than or equal to the mean annual income of teachers in Washington. In a current study, a random sample of 15 teachers from Florida and an independent random sample of 15 teachers from Washington have been asked to report their mean annual income. And the data is listed in the table. The population standard deviation for the mean annual income of teachers in Florida and Washington are estimated at 6,300 and 6,200 respectively. It is also known that both populations are approximately normally distributed. At the 0.1 level of significance, is there significant evidence to reject the claim that the mean annual income of teachers in the state of Florida is greater than or equal to the mean annual income of teachers in Washington? Perform your one-tailed test and fill in your table below. So the claim is your null hypothesis because mean 1 is greater than or equal to mean 2. Our alternative hypothesis is that mean 1 is less than mean 2. So we end up doing a left-tailed z-test in order to do this. So go ahead, put that into your calculator, find your test statistics and your critical values. Again, since you're going to the left, you're going to use negative z of 0.1, and then you can go ahead and decide, remembering that they're wanting to know, is there enough evidence to reject the claim that it is greater than or equal to? All right, the next one then is still doing the hypothesis test for the difference between two means, doing the z distribution when we have the population standard deviation. This time we are going to use the statistics instead of having to type the list in. It says a study using 2 random samples of 35 people each found that an average amount of time those in the age group of 26 to 35 years spent per week on leisure activities was 39.6 hours, and those in the age group of 46 to 55 years spent 35.4 hours. Assume that the population standard deviation for those in the first group found by the previous studies is 6.3 hours, and the population standard deviation of those in the second group found by a previous study was 5.8 hours. At the alpha level of 0.05, can it be concluded that there is a significant difference in the average times each group spends on leisure activities? So on this case, we again are just going to do our stat button. So if I find my stat button here, so I'm going to go to stat. Oops, got to turn my calculator on. Stat. Go cursor over to tests. And again, we're going to do number 3, which is our 2 sample z-test. So I'm going to press number 3. This time, instead of doing the data, we're going to do the stats. So I'm going to cursor over, hit enter on stats so that the stats is blinking. And then I have to input my standard deviation. So my standard deviation for those in the first group was 6.3 hours. And in the second group, my standard deviation was 5.8 hours. And then the X bar is your mean. So your mean for the first group says it was 39.6 hours. And then it wants the number in the first group, which was using 35 people. So I'm going to put 35 in there. Then it wants the mean for the second one. The mean for the second group was 35.4 hours. 35.4. And the number for the second one again is 35 because they did 35 for both of them. Our hypothesis here, we wanted to know if there's a difference. So if it asks me if there's a difference, I'm going to use the not equal. So I'm going to make sure it's blinking on the not equal. Once I've got my data in there, standard deviation 1 is 6.3, standard deviation 2 is 5.8, mean 1 is 39.6, N1 is 35, mean 2 is 35.4, N2 is 35, and then mean 1 is not equal to 2. I'm going to cursor down to where it says calculate, and I'm going to enter on that. And it's going to give me the z-value. The z-value, 2.9016. 2.9016. My p-value, 0.0037. 0.0037 if I go to 4 decimal places. So looking at my questions, wants to know if it's a left-tailed test or a right-tailed test or a two-tailed test. Since this is a not equal, we have to say it's a two-tailed test. Then we have to find our critical value. When we find our critical value, since it's a two-tailed test, we're going to use z sub 0.05 divided by 2. And it's going to be plus or minus this value. So you could do negative z sub 0.05 divided by 2 and positive 0.05 divided by 2. On your graphing calculator, you would use the inverse norm, and you'd use the 0.05 divided by 2, which is 0.025. Either way, when you do that, you should get plus or minus 1.960. Plus or minus 1.960. Again, on your graphing calculator, you do second bars, and then number 3 is inverse norm, and you would use 0.025 to find the area to the left, mean of 0, standard deviation of 1, and that gives you the negative 1.960. And then if you wanted the positive, you would do 1 minus that. But you know it's going to be plus or minus that value. So again, wants to know if we can accept or reject the claim being, is there a difference? So if I again look at my picture here, I'll find my picture. There it is. So negative 1.96 and positive 1.96 would separate our critical areas. The null would be in the middle. Our test statistic was 2.9016, which is greater than 1.96 and would fall in the alternative hypothesis section. And so in this case, that was our claim, is that there is a difference, so we are going to accept the claim. Other way, if I look at my p-value, I had a p-value of 0.0037, which is less than the 0.025. We are going to reject the null since my p-value is less than my alpha value. And so if I'm going to reject the null, that means I'm going to accept the alternative hypothesis, which is what our claim was, that there was a difference. Alright, so you are going to do another one that says a study conducted by the research department of a pharmaceutical company claims the annual spending per person for prescription drugs for allergy relief is greater than or equal to the annual spending per person for non-prescription allergy relief medicine. A health insurance company conducted an independent study and collected data from a random sample of 270 individuals for prescription allergy relief medication. The sample mean is found to be $17.8 per year, with a sample standard deviation of $5.3 a year. They have also collected data for non-prescription allergy relief medicine. An independent random sample of 260 individuals yielded a sample mean of $18.2 a year and a sample standard deviation of $4.4 per year. Since the sample size is quite large, it is assumed that the population standard deviation of the sales per person for prescription and non-prescription allergy relief medicine can be estimated by using the sample standard deviation values given above. Is there sufficient evidence to reject the claim made by the research company of the company at the 0.1 levels of significance? Perform a one-tailed test and fill in the table below. So the claim is that the mean of the first one is greater than or equal to the mean of the second one. So this time the null is actually the claim, and your alternative hypothesis is that mean 1 is less than mean 2, so we are doing a left-tailed test. The type of statistic is the z-test. So again, you are going to go ahead and put your data into the calculator using the stat button and then number 3 for 2 sample z-test. And then you are going to put the data in and see if you can answer the rest of the questions. By the way, these questions are the same ones that we used for the confidence intervals. And so if you go back and check your confidence intervals, if 0 was in your confidence interval, was what the question was when we were doing those confidence intervals. And if the confidence interval contained 0, then you accepted the null. If the confidence interval did not contain 0, you would have rejected the null. So you can go back and see if those agree with the answers that you get as far as using the test statistic or the p-value in order to do your hypothesis test. So there's actually 3 ways. You can check the critical value, you can check the p-value, or you can look at the confidence interval. If 0 is in the confidence interval, then you are going to accept the null. All right, the next one we are doing the hypothesis test for the difference between 2 means dependent samples. A dietitian wishes to see if a person's cholesterol level will change if the diet is supplemented by a certain mineral. 6 randomly selected subjects were pre-tested, then they took the mineral supplement for 6 weeks. The results are shown in the table. Cholesterol level is measured in milligrams per deciliter. Can it be concluded that the cholesterol level has been changed at an alpha level of 0.10? Assume the variable is approximately normally distributed. So what we're going to do is go ahead and put those numbers into our list. So I am going to go to Stat, and I'm going to hit 1 to edit. And then again, I'm going to go up to the top. I'm going to clear that list out. So clear and enter up to the top, clear and enter, and then I've got to put my data in from my list. So 210, 235, 208, 190, 172, and 244. And then my after list, 190, 170, 210, 188, 173, and 228. So once I have my data in list 1 and list 2, I'm going to put a formula in list 3 to do the difference so I don't have to subtract myself. On Alex, they will have the difference in the table, but this way you can double check, make sure your numbers are right. So highlight L3 up at the top, and then down in the bottom we're going to put a formula in there. And so we're going to hit second function, number 1 to put L1, minus second function, number 2 to hit L2. We want to do list 1 minus list 2. When we enter in list 3, it will then do the calculations. And when you're on Alex, those numbers will already be in the table, but that way you can see and make sure that you have your list in there correctly. So once our list is in there, then we are going to press Stat. So again, I'm going to go to the Stat button. I'm going to cursor over to Tests, and this time I'm going to do number 2 to do a t-test. And so just the plain number 2, I'm just going to do the plain t-test. I am going to use the data, so I want data highlighted and I want to hit enter on that so my cursor is blinking on there. My mean value is going to be 0, and then for my list I need list 3. If you don't have list 3, you're going to hit second function and number 3. Second and number 3 will give you list 3. Frequency of 1, then I want my alternative hypothesis, wants to know if it's been changed, And so we're going to use the not equal, which is what we have there. If it's not highlighted, highlight it and then enter on that so that it's the not equal. And then cursor down to calculate and go ahead and calculate your information. So my t value is going to be 1.6079. 1.6079. My p value 0.1688. 0.1688. So, is this a left-tailed test or a right-tailed test or a two-tailed test? Since we're doing the not equal, it's a two-tailed test. We got to find our critical t values. And so when you do that, on Alex is the easier way. You can use the graphing calculator and do inverse t. But on the Alex calculator, you're going to use plus or minus the t sub. And since it's a two-tailed test, you're going to take alpha divided by 2. So 0.10 divided by 2. Degree of freedom is going to be 5. N minus 1 would mean you're going to use 5 for your degree of freedom. So you should end up with plus or minus 2.015. Plus or minus 2.015. Then it wants to know, should we accept or reject the claim? So again, I've got my picture drawn here. It's a two-tailed test, so negative 2.015 and positive 2.015. The null would be in the middle. Since my test statistic of 1.608 is between negative 2.015 and positive 2.015, we would accept the null. And if we're accepting the null, that means we would assume that they are equal. The claim is that they had been changed, so we're going to reject the claim. Again, you can also use the p-value, or you could use the confidence interval that we found when we were doing confidence intervals in order to answer that last question. So now you'll try one on your own. It says a consumer product testing group is evaluating two competing brands of tires, brand 1 and brand 2. Treadwear can vary considerably on the type of car, and the group is trying to eliminate this effect by installing the two brands on the same random sample of 8 cars. In particular, a car has one tire of each brand on its front wheels, with half of the cars chosen at random to have brand B on the left, and the rest have brand 2 there. After all the cars are driven over the standard test course for 20,000 miles, the amount of tread wear in inches is recorded in the table 1. So again, you're going to want to go to list 1 and list 2, put brand 1 in list 2, brand 2 in list 2, and then do the calculation on list 3 of L1 minus L2, and that difference should show up. That way you can tell that you've got all your numbers typed in right if your numbers in that difference column match up with the ones that are listed on Alex. And so again, you are going to go ahead and conduct your test by hitting the stat button, hitting tests, doing 3 for your 2 sample, or hitting 2 for your t-test. We're not going to do a 2 sample test, we're just doing the plain t-test. So stat test, press number 2 for the t-test, and use your data. And make sure that the list is list 3, and go ahead, find your test statistic, p-value, and then try to answer the questions as far as if that matches up with, if you can say that conclude that the mean tread wear of the brands differ. So the alternative is if they differ. If they get the null, then we'd have to say no, they do not differ. Alright, the next ones we're going to do is the hypothesis test for the difference between two means using the t distribution. And again, you have the option to do data or to do stats, and so we're going to do some both ways. And so first one we're going to do is going to have the data. It says, is there a significant difference at the alpha level of 0.10 in the mean heights in feet of waterfalls in Europe and the ones in Asia? Which means mean 1 would not equal mean 2 if there is a difference. So again, you have to put your lists in list 1 and list 2. So go ahead and hit the stat button, number 1 to edit. You can see I've already typed my list in there, but if not, you may want to pause your video to get your list in there. Once you get your list in there, you're going to hit the Stat button and cursor over to Tests. So this time we are doing the t-test. So we're doing the 2-sample t-test, which is number 4. You can either cursor down to number 4 and enter, or you can just press the number 4. We are going to use the data. So data should be highlighted. If not, highlight and hit enter. We are going to use list 1 and list 2, which should already be in there. But if not, second function 1 to list 1, second function 2 for list 2. Frequencies, both 1. In this case, we wanted mean 1 not equal to mean 2, which is the choice that I already had highlighted. But if not, highlight and enter. On the pooled, on Alex, they're going to do yes, they want them pooled. So make sure you have yes highlighted and enter on yes. Then once you're done getting your data in there, you can go ahead and calculate. So my t-value there is 0.2093. 0.2093. My p-value 0.8369. 0.8369, at least if we're going to 4 decimal places. The degree of freedom is 16. To do your degree of freedom on your t-test, you are going to take the degree or the number from 1, the number from 2, add those together, and then subtract 2. So in this case, we had 9 in list 1, 9 in list 2, which is 18, and then you subtract 2 and you get 16 for your degree of freedom, which they already have there for you. So if we are looking at our questions then, once we've got our statistics, is this a left-tailed test, a right-tailed test, or a two-tailed test? This would be a two-tailed test because it's a not equal. To find our critical value, since we're doing a two-tailed test, we have to take alpha divided by 2. So plus and minus t sub 0.10 divided by 2 with 16 as our degree of freedom. You could again use your graphing calculator and do inverse t of 0.05 and 0.95 with a degree of freedom of 16. When you do that, you should come up with plus or minus 1.746. Again, to get inverse t, if you're doing that on your graphing calculator, second bars and number 4 is your inverse t. If I do 0.05 with the degree of freedom of 16 and enter that in, I get the negative 1.746. And then if I use the 0.95, I'll get the positive 1.746. Usually the Alex calculator is easier than the graphing calculator, but certainly you could use the graphing calculator. So wants to know if we should accept or reject the claim. Again, I've got my scribbling here. If I can find my drawing. So I had negative 1.746 and positive 1.746. My test value was 0.293, which is in the middle, which would be the null. I would accept the null then, which means I would reject the claim. I could also use my p-value. Since my p-value 0.8369 is greater than my alpha value of 0.10, means that I would accept the null. So we are going to accept the null, which means we are going to reject the claim. So then you're going to try the next one on your own. It says a purchasing manager for a large university is investigating which brands of LCD projectors to purchase to equip the smart classroom. Of major concern is the longevity of the light bulbs used in the projectors. The purchasing manager has narrowed down the choices of projector to 2 brands, InFocus and Proxima, and wishes to determine if there is any difference between the 2 brands in the mean lifetime of the bulbs. The purchasing manager obtained 13 projectors of each brand for testing over the last several academic terms. The number of hours the bulbs lasted in each of the 13 machines is given in the table. So again, you'll want to enter that data into list 1 and list 2. Assume the population of light bulbs or lifetimes are normally distributed and that the population variances are equal. Can we conclude at the 0.01 level of significance that there is a difference in the mean lifetimes of my bulbs? So I'm doing a two-tailed test. My null is mean 1 equals mean 2. My alternative hypothesis, mean 1 does not equal mean 2, and that's my claim. So again, we are going to do the t-test. The degree of freedom on this one is going to be 24, because again, I would take 13 plus 13, which is 26. 26 minus 2 is 24, so my degree of freedom is 24. You are going to find the values of your test statistics and your critical values as well as your p-values and answer the question if we can conclude that there is a difference. In other words, should we accept the alternative hypothesis? Again, you could look at your confidence interval because that's the same question we did when we did the confidence interval. If it contains 0, you should accept the null. If it does not contain 0, then you would accept the alternative hypothesis. And so 3 different ways we could answer that last question, just to give you some practice at that. All right, so the next ones we're going to again do the t-test, and this time we're just going to use the statistics. And so it says a study was done to see if there's a difference between the number of sick days men take and the number of sick days women take. A random sample of 9 men found the mean number of sick days taken was 5.5. The standard deviation of the sample was 1.23. A random sample of 7 women found that the mean was 4.3 days and a standard deviation of 1.19 days. At an alpha level of 0.05, it can be concluded that there is a difference? So again, we're doing that two-tailed test. This time we can just go ahead. I'm going to turn my calculator back on and hit stat. Hit stat, cursor over to tests, and we are going to do the t-test. So we are going to do number 4, the 2-sample t-test. This time we are going to do the stats. So cursor over to stats and enter on that so it's highlighted. And then we got to put our information in from our problem. So mean 1 was 5.5. Standard deviation 1 was 1.23 for the men. The number of men that they sampled was 9. For the women, mean 2 was 4.3 days for the women. Standard deviation for the women, 1.19. And the number of women sampled was 7. So we input our data, 5.5 for the mean for the men, 1.23 standard deviation, 9 were sampled. For the women, 4.3 days, 1.19 standard deviation, 7 were sampled. Again, we're doing that two-tailed test to see if there is a difference. So we want to have the not equal highlighted. And for pooled, again, we want to have yes. Cursor down to calculate and calculate our information. So our t-value, 1.9630. 1.9630. P-value, 0.0698. 0.0698. My degree of freedom is 14 there. Again, when I do my degree of freedom, I'm going to add the 2 together. 9 plus 7 would be 16, and then subtract 2. So you can see they got 14 for the degree of freedom. So, critical value, again, it's a two-tailed test. You're going to do t sub 0.05 divided by 2 with 14 degrees of freedom, plus or minus that, and so we should come up with 2.145, so plus or minus 2.145. Should we accept or reject the claim? The claim being that there is a difference, which is our alternative hypothesis. So again, if I look at my drawing, if I have negative 2.145 and positive 2.145, the null would be in the middle. Our test statistic of 1.96 would be in the middle. We're going to accept the null which means we are saying that they are equal, so we are going to reject the claim that there is a difference. Again, we could have used our p-value of 0.0698, which is greater than the 0.05. Since my p-value is greater than my alpha value, accept the null, which means we're going to reject the claim. Again, you could look at your confidence interval also. If 0 is in your confidence interval, then you're going to accept the null. All right, now you're going to try one that was from Alex, the hypothesis test for the difference between two means, doing our t-test. An industrial plant wants to determine which of two types of fuel, electric or gas, is more cost efficient, measured in cost per unit of energy. Independent random samples were taken of the plants using electricity and plants using gas. These samples consisted of 13 plants using electricity, which had a mean cost unit of $54.50 and a standard deviation of $8.30. And 10 plants using gas, which had a mean of $53.10 and a standard deviation of $7.93. Assume that the population of costs per unit are normally distributed for each type of fuel, and assume that the variances of these populations are equal. Can we conclude at the 0.1 level of significance that the mean cost per unit of plants using electricity is greater than the mean cost per unit for plants using gas? We're going to do a one-tailed test. So our null hypothesis is mean 1 less than or equal to mean 2, and our alternative hypothesis is mean 1 greater than mean 2. You could also use mean 1 minus mean 2 is less than or equal to 0, and mean 1 minus mean 2 is greater than 0. I like to either just use 1 on one side and 1 on the other. But again, we are going to do the t-test, and for our degree of freedom, we would add 13 from each plant, so 13 plus 13. Oops, no, we didn't have 13 from each plant. We had 13 and 10. 13 from the first plant and 10 from the second plant. So 13 plus 10 was 23. 23 minus 2 gave us 21 for our degree of freedom. So 13 plus 10 minus 2 was our formula. So again, go ahead and hit the stat button, cursor over to test, and press number 4 for your 2 sample t-tests. Enter in your data and find your statistics and see if you can answer the question, can we conclude the mean cost per unit for the plant using electricity is greater? So should we accept the alternative hypothesis? Again, you can go back and look at your confidence interval that we did for this question. If it contains 0, we should accept the null. If it does not contain 0, we would accept the alternative hypothesis, which is our claim. All right, the next one we have is the hypothesis test for the difference between two proportions. On these ones, we are just going to do stats. We're not going to do any that have data, so we're just going to do the stats. It says in a nursing home study mentioned in the chapter opening statistics today, the researchers found that 12 out of 34 randomly selected small nursing homes had resident vaccination rate of less than 80%, while 17 out of 24 randomly selected large nursing homes had a vaccination rate of less than 80%. At an alpha level of 0.05, test the claim that there is no difference in the proportion of small and large nursing homes with a resident vaccination rate of less than 80%. So if there's no difference, that means they're equal. So P1 would equal P2, or you could use P1 minus P2 equals 0. Either way is correct. Your null hypothesis, that P1 does not equal P2, or P1 minus P2 does not equal 0 again. So we, again, are just going to hit our stat button. I'll turn my calculator on. I'm going to press the word stat again, and I'm going to cursor over to test like I did before. This time we are going to do number 6. Number 6 is the 2 proportion z-test. 2 proportion z-test. So number 6 is what we want. You can just hit the number 6, and then we got to put our information in there. And so when I have X1 and N1 for my first sample, I had 12 out of 34. So X1 is going to be my 12, N1 is going to be my 34. For my X2 and my N2, I had 17 out of 24. So my X2 is the 17. My N2 is the 24, 17 out of 24. So we had 12 out of 34, 17 out of 34. Again, we're checking if there's no difference. So our alternative hypothesis is the not equal. If it's not highlighted, highlight it and enter, then go down to calculate. So our Z value is going to be negative 2.6661. Negative 2.6661. Our P value, 0.0077. 0.0077. So, wants to know, is this a left-tailed test, a right-tailed test, or a two-tailed test? Again, this is going to be a two-tailed test. So when you're doing your critical value, you're going to do plus or minus Z sub 0.05 divided by 2, since it's a two-tailed test. And so you are going to have plus or minus 1.96. Again, on the graphing calculator, you could, I'm going to clear this out, you could use the distribution menu like we did before and do second function distribution, and we'd be doing the z-test, so we're doing inverse normal, which is number 3, and the area would be 0.5 divided by 2, 0.05 divided by 2, mean of 0, standard deviation of 1, and when I put that in there, you can see I get the negative 1.96 or positive 1.96 then, plus or minus 1.96 if I round that to 2 places. So again, if I'm checking to see if I should accept or reject the claim, I like to look at my little picture here. But you can see that I had negative 1.96 to positive 1.96. My test statistic is less than the negative 1.96. So it's in that end section where I would be accepting the alternative hypothesis. And this time, our claim was actually the null hypothesis. The null hypothesis said there was no difference. Well, we're saying there is a difference. So we are going to reject the claim that there is no difference. All right, so now you are going to try one from Alex, the hypothesis test for the difference of two population proportions in a random sample of 281 potential voters registered in the state of Florida. 118 indicated they plan to vote in the next general election. So 118 out of the 281. In an independently chosen random sample of 230 potential voters registered in Rhode Island, 71 indicated they plan to vote in the next general election. So 71 out of 230. Can we conclude at the 0.05 level of significance that the proportion of P1 of all potential voters in Florida who plan to vote is greater than the proportion P2 of all potential voters in Rhode Island who plan to vote? So this is a one-tailed test. My null hypothesis is that P1 is less than or equal to P2. Again, you could have P1 minus P2 is less than or equal to 0. And then my alternative hypothesis, P1 is greater than P2, which is my claim. Is it greater? So we could also have P1 minus P2 is greater than 0. We have a z-test that we are going to do. And so we are going to find our test statistic, our p-value, and then can we conclude that the vote is greater? In other words, should we accept the claim, which is our alternative hypothesis? So go ahead and put that in there. Again, stat, go over to tests, and test number 6 is the one that you want to do, which is your two proportion z-test, number 6. All right, the last kind of hypothesis test that we're going to do here in Chapter 9 is the difference between two variances. So you have to be careful. On the graphing calculator, you have to use the standard deviation instead of the variance. So if the variance is given, you have to do the square root of the variance for the standard deviation. So the CEO of an airport hypothesizes that the variance in the number of passengers for American airports is greater than the variance in the number of passengers for foreign airports. At an alpha level of 0.10, is there enough evidence to support the hypothesis? The data in the millions of passengers per year are shown for select airports. Use the p-value method, assuming the variable is normally distributed and the samples are random and independent. So again, you would want to put your list in list 1 and list 2. Hit the stat button and hit number 1 in order to do your edit. And then go ahead and put your data in. As you can see, I've already entered my data into list 1 and list 2. So once you have your data in list 1 and list 2, you are going to hit the stat button again, cursor over to tests, and this time we have to cursor way down to E. And once you get to E, you'll see that you have the 2 sample F test. E is the 2 sample F test. That's what we want to do here. So I am going to go ahead and enter on that. And of course, again, we have the choice of doing data or statistics. So this first one we typed in our list, we're going to do data. So I'm going to enter on data so it's highlighted. My list I've entered into list 1 and list 2. Again, second function 1 will change that to list 1. Second function 2 is list 2. Frequencies are both 1s. And then here we want to do the standard deviation. On Alex, we're going to use the variance, so it's going to be squared. But it's going to be the same thing as far as answers if you use standard deviation. And so we can go ahead and use that on our calculators. And so in this case, we want to see if the number of American airports is greater. So I want to have the greater highlighted. So I'm going to go over to greater and then go down to calculate and go ahead and calculate my statistics. And so my F value is going to be 2.5699. 2.5699. My p-value 0.2336. 0.2336. So this asks if it's the left tail test, a right tail test, or a two tail test. Since we're doing greater, it's a right tail test. And then we're using our p-value to check if we should accept or reject the claim. So since my p-value is 0.2336, and that's greater than 0.10, 2.336 is greater than 0.1, we are going to accept the null. And if I look at this, my alternative hypothesis is my claim, so I'm going to have to reject my claim on this one. You can also do the critical value. Sometimes on Alex you will do the critical value, which you can do on your Alex calculator by doing F sub 0.10. The degree of freedom in the numerator would be 5, n minus 1. Degree of freedom in the denominator is 3. The foreign airports, we had 4 minus 1. And so you could also use the critical value method. This one just specified to do the p-value method. And then we're going to do the hypothesis test for the difference between two variants using statistics. So again, most of the time on Alex, they are going to have you just have the data, so you can just use the statistics. But watch to see if they give you the variance or the standard deviation, because in the graphing calculator, you need the standard deviation. So if the variance is given, you have to take the square root of your variance when you put it in. And we'll do that here on this next one. A medical researcher wishes to see whether the variance of the heart rates in beats per minute of smokers is different from the variance in heart rates of people who do not smoke. 2 samples are selected and the data are shown. Using the 0.05, is there enough evidence to support the claim? Assume the variable is normally distributed. So, again, if we just have the data, we're going to go ahead right away, or if we just have the stats, we're going to go ahead right away and hit the stat button, cursor over to tests, and we're going to cursor all the way down to the E test. So once we get that sample F test, we're going to enter on that. And this time we're going to do stats. So we want stats highlighted. And so here's where we have. They want the standard deviation. In the problem, they give us the variance. And so we're going to do second function and hit the x squared button so that we can do the square root, which is above that. I want to do the square root of my variance, and my variance is 36. Now you probably could have figured out the square root of 36 was 6 and just type 6 in there, but you can see the calculator figures that out. N is 26. N1 is 26, so I'm going to put that in. And then I'm going to do my standard deviation for my second sample. This variance is 10, so the square root of 10 isn't very nice, but we'll go ahead and put in second function, the x squared button to put square root, put our 10 in there, and you'll see when I hit enter that the calculator figures out the square root of 10, which is a nice big long decimal number. N2 is 18, it says, so I'm going to put 18 in for N2. And we want to see if the smoker is different, so we are going to do is not equal in this case. So I want to make sure the not equal is highlighted, and then I'm going to calculate. So in this case, my F value is just 3.6. My P value is 0.0084. 0.0084. So, wants to know, should we accept or reject the claim based on the P value? Since my P value is 0.0084, and that is less than 0.05, we are going to reject the null, and so that means we are going to accept the alternative hypothesis, which is that they are different. So we are going to accept the claim that they are different. And so last one for you to try, one that's from Alex. It says a psychologist studied the alcohol consumption patterns of people in two age groups. One group consists of people aged 21 to 35. The other consisted of people aged 36 to 50. Psychologists interviewed a random and independent sample from each group. She assigned a score from 0 to 100 to each individual. A score of 0 meant no alcohol. According to factors such as frequency and the amount of alcohol consumed, the results from this study are summarized in the table. So, N1 is 28, N2 is 29, mean 1 45.9, mean 2 49.2. You really don't need to know those, but here you again have the variances. Notice it's the standard deviation squared, so it's the variance. So when you put it into the calculator, you got to make sure you do the square root of 216.09 and the square root of 506.25. So again, hit the stat button, cursor over to tests, and go down to E, which is your F test, and calculate your statistics there. The critical value on Alex, because it's a left-tailed test, you're doing a less than. You have to do F sub 1 minus 0.01 or 0.99 in order to get those critical values. And go ahead and see if you can answer those questions below.